In this lesson, we're going to talk about trigonometric functions, or trig functions. So we're going to talk about transforming them and what they are and how they're used to model various phenomena, specifically periodic phenomena. So things that rotate, so that you have a starting place and then you'll do something and you end up back at your starting place. Like think of like a wave or anything that rotates, tires, gears, anything. So we're going to run through some definitions of sine, cosine, and tangent. We're going to briefly discuss the unit circle and how to use it to find trigonometric function values. And then we're going to discuss moving trig functions around. So shifting left, right, up, down, changing the amplitude, which is your vertical stretch or shrink, and then talking about your period, so how often the cycle repeats. And then we're going to talk about some applications of trig functions. So here's some vocab. We got sine, cosine, tangent, and then sinusoidal is any graph that takes the shape of a sine or cosine curve. So this is a sine curve right here. It's a function, sine of x. I'll write that down. So this as a function is written as sine of x. So this is a function, like y equals sine of x. Okay. And if you recall, the sine ratio is the ratio of the opposite leg to the hypotenuse in a right triangle. So if we have a right triangle and we're taking this angle, theta, the sine, okay, hang on. We'll call this x, we'll call this one y, and we'll call this z. So the sine of the theta angle equals the opposite side, which is y, over the hypotenuse, which is z. In class, these are graphed using a unit circle, where instead of a hypotenuse of any number, we say, no, at the unit circle, this hypotenuse is 1. And then we can create a trig function based on the values of sine for any angle. And we usually use radians. This is what we will use in this class. And then cosine is the ratio of the adjacent leg to the hypotenuse in a right triangle. And we can write this as a function, cosine of x. So you can type in cosine of x into Desmos, and you will see a graph that does not look like this because this is a sine graph. All right, y'all, I will fix this. Cosine curve. All right, hang on. Okay. This is a cosine curve. It looks just like a sine curve, except shifted at 90 degrees, or pi over 2. So sine curve, you see, crosses at 0, 0. Cosine curve crosses the y-axis at 1. And the cosine curve is defined the same way, using the unit circle, just different values of cosine for different angles. So for example, the cosine of 90 degrees is 0, because this is where it is on the graph. And tangent is the ratio of the opposite leg to the adjacent leg of a right triangle. Here's the graph of tangent. See these dotted lines? These are not part of the graph. These are the asymptotes. And remember that I'm going to write this. Tangent of some angle x equals sine of that angle over cosine of that angle. That's important for tangent. The tangent is sine over cosine. All right, let's keep moving here. Let's talk about amplitude, period, and phase shift now. Okay, amplitude is the distance from a crest up here to the halfway line here. So this is the amplitude. So the amplitude is the distance from a crest or the peak or the bottommost point or the topmost point to the halfway point. In this case, it's the x-axis, but sometimes this is shifted up or down, in which case the halfway point would also be shifted up or down. And then period. Is the length or the time, how long? no, I'm going to write this differently. So the period is how long this graph takes to repeat, or otherwise, you can think of this as how many x values it takes to get from one peak to the other. So the period goes from one peak or valley to another, to the next one. I guess I shouldn't say to another. We should say to the next one. So for example, this goes from -3 pi over 2 all the way to pi over 2. That is a distance of 2 pi. Therefore, this function will repeat every 2 pi. And lastly, phase shift is just a horizontal shift. So shifting left and right. All right, and lastly, fun thing about amplitude, period, and phase shift is that we can determine each of these just given a function. So you'll see something that looks like y equals a sine or cosine of bx plus c. This is and then sometimes you'll see a plus d out here. So sine of x, you can also multiply this something times your x. We can add something in here, add something on the outside, and then multiply it. These all deal with the same things as what we've been talking about with function transformations. So this a will be your vertical stretch or shrink. In other words, your a is the amplitude. Which will drag this top point up higher or lower. And that's all the amplitude does. So now b deals with the period. So the period of a function is 2 pi divided by b. For example, this graph is just y equals sine of x, where this is, you can think of this as sine of 1x. So this b value is 1. So the period is 2 pi divided by 1, which is 2 pi. And we already said that the period was 2 pi because it takes 2 pi to get from this peak to this other peak. So the period equals 2 pi divided by this b value. And then the phase shift is, we can call this PS, phase shift, equals negative c divided by b. And then d moves it up or down, just like any other function. And this is how you can calculate amplitude, period, or phase shift using your different parts of the function. And we'll do a couple examples with this. If you haven't taken trig yet, stay with me. If you have, then this is review for you. So let's go forward and let's apply this. And if this is new for you, email me if you have any questions, okay? Okay, the unit circle. The unit circle lists various trig values, and it's important to know how to read this. So this, I just gave you one. You can just Google this, and it'll pop out a million that looks just like this. So we've got different quadrants. So think of this as a coordinate plane. And this is the y-axis. And this is the x-axis. And this is a circle, a unit circle with a radius of 1. That's why if we start in the center and we go out over here, this point is 1, 0, because we went over 1 and up 0, because this radius is 1. And now, to read this unit circle, See how we have all of these coordinate points over here? So the unit circle defines the sine and cosine of each angle. So this is angle pi over 6 right here, or 30 degrees. And we're calculating the sine and cosine values by creating a right triangle here. And this is where what the unit circle is, where it comes from. So in this right triangle with this 30-degree angle, pi over 6 angle, and this length of this hypotenuse is 1 because it's a unit circle with a radius of 1. We're trying to find the length of this side, y, so how high we go up to this point, and how far over we go to this point, x. So that's what these coordinates mean. This means that this x value is root 3 over 2, and this y value is 1/2. And now, this literally means that, okay, remember that, let's start with sine. Sine equals the opposite over the hypotenuse. So sine of 30, I'm going to use pi over 6. So sine of pi over 6, or 30 degrees, equals the opposite side, so y, over the hypotenuse, which is 1. And this y value is 1/2, which means that this sine of pi over 6 equals 1/2. In other words, I'll write this over here. The y coordinates correlate to the sine. So sine of the angle. And the x coordinate correspond to the cosine of the angle. And then keep in mind that tangent is sine over cosine. So these are all key things that'll help you read this chart and get us some exact values of the different trig functions at certain angles. So I have a bunch of examples down below, I believe. So let's go through them. Okay. Maybe I can zoom out for the sake of the video. All right. So sine of 0 means this is our angle. This is the angle. So 0 degrees or 0 radians. So that means we're going out to here, and this is our point, 1, 0. So sine of this is the y value, which is 0. So that means sine of 0 equals 0. How about cosine of 0? What's the cosine of this angle? It's the x value, which is 1. And then tangent is sine of 0 over cosine of 0, which equals sine of 0 was 0, cosine of 0 was 1. So this is 0 over 1, which is just 0 as well. Now let's look at pi over 4. So this is the angle, our nice 45-degree angle. We like this one. All right, so we're looking at this. Sine is the y value, so sine of pi over 4 is just root 2 over 2. Cosine of pi over 4, that is the x value of that coordinate point, which is also root 2 over 2. Finally, tangent of this is sine over cosine, which is root 2 over 2, all over root 2 over 2, which these are the same values, so that means tangent is 1. So this tangent is 1. So tangent of pi over 4 equals 1. That's always a nice one to have memorized. All right, now let's take a look at this bottom row. Whoops. Okay. Sine of pi over 2. Let's go up to pi over 2. We're dealing with this point. So sine of pi over 2 is that y value, which is 1. Cosine of pi over 2 is that x value, which is 0. And tangent of that line is sine over cosine, which is 1 over 0. Whoa, 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 we can't do that. All right, this is undefined, folks. Which also means that this tangent is undefined because there's some symmetry in this circle, which you'll see patterns here. So like this is root 2 over 2, root 2 over 2, this is root 2 over 2, and the negative root 2 over 2 because we go down, because keep in mind this is like our coordinate plane, and this is the y-axis, and this is the x-axis. So take a look at the symmetry of this unit circle. And just let me know if you have any questions about how to find any trig function values. Okay, and then this last one, determine if the sine, cosine, tangent are positive, negative, 0, or undefined. So 3 pi over 4, I can show kind of like this. 3 pi over 4. The sine of 3 pi over 4, let's see, 3 pi over 4. Oh, all right. I'm going to have to write this up here, but just keep in mind if you're working on the paper, I'm still with you. So we're going to deal with 3 pi over 4, which is this angle right here, this 135 degrees. Also, another thing I should have said is our angles are all building off of this line right here. So 0, 30, 45, 60, 90, right angle. And then we just keep going around the circle. Alrighty. So 3 pi over 4. The sine is that y value. So sine of 3 pi over 4 is positive because we're still above this x-axis. How about cosine? The cosine of 3 pi over 4, this is the x value. Oh, we passed that y-axis, which means this one is negative. And then the tangent, well, the tangent is sine over cosine, which means we have a positive over a negative, which will be a negative as well. This tangent will actually be a negative 1, if you're curious about that. All right, so that's that for that one. What's our last one? 3 pi. Ooh, okay. 3 pi. I don't see a 3 pi on this. All right, so starting here at 0, we go around. This is 1 pi. 2 pi, and we keep going again. 3 pi, and we're ending up here. This is where we're at. So 3 pi. So the sine of 3 pi equals, not equals, is positive, negative, 0, undefined. This is on the x-axis, which means you don't go up at all. So this one is 0. Now the cosine of 3 pi is negative because we go to the left from the origin. So this is negative. And now the tangent. Tangent is sine over cosine. This will be 0 over a negative number, which will be 0. So the key here is knowing that this is like a coordinate plane. Your x and your y correspond to cosine and sine, respectively. And just knowing that we're in the coordinate plane, all of these radii are 1, and that the center of the circle is like the origin. Also, that tangent equals sine over cosine. That is very important as well. All right, so now let's talk about some finding amplitude, period, and phase shift. All right, recall. I can zoom in a little bit and then write it. I'll write it above. Okay. In the function a times sine of bx plus c plus d, the amplitude is a, the period equals 2 pi over b, and the phase shift is negative c over b. And then the d, in this 4, we'll just shift it up 4. That's all that 4 will do. It won't change any other value, though, of the amplitude, period, or phase shift. All right, so the amplitude is our A value, which is 3, because this is A, this 2 is B, this C is also 2. Excuse me, I wrote a B, but I meant to write C. And then this 4 is D. All right, so the amplitude is A, which is just 3. Now the period equals 2 pi divided by B, which is 2 pi divided by 2, which is pi. So this means our graph will repeat every pi units. In class, see, this makes sense because this 2 is like a horizontal shift, and if this is larger than 1, that means it's a horizontal shrink, which in turn makes our period shorter. Now our phase shift is negative C divided by B, which is negative 2 over 2, which is 1, which means, negative 1. Which means that we will go to the left 1. And that's going to be it for that. So just remembering these quick little formulas, also understanding what period really is. That means this curve will repeat every pi units. This means we're shifted to the left 1. And this amplitude 3 means that from the highest point to the middle point, it'll be 3 units. Or in other words, from the highest point to the lowest point, it will be 6 units. All right, let's keep moving. All right, find a trigonometric function that represents the graph below. If you recall on the first page, the sine curve goes through the origin. Our graph here goes through the origin. So that means I'm going to write a sine curve. So we're going to choose sine. Let's figure out what the amplitude is. This starts at 0, and we go up to 5. So that means the amplitude is 5. Period, and phase shift, and vertical shift. All right, let's find all of these items. Vertical shift is nice because we're starting at 0, 0, so that means this vertical shift is 0. This is sine, which crosses at the origin, which means we didn't go left or right at all, which means our phase shift is also 0, which really means we're not going to have a C term. Okay, now we know the amplitude is 5, so now we just need to find the period. So how often this curve will repeat? All right, so this might be kind of difficult to see, but you can go from peak to peak, but we don't have 2 peaks, do we? But we know that the sine curve will start over once we go through all the way through across the origin, from here, all the way up here. This is 1 cycle, actually, because then it'll start going down again, then we'll reach a valley, and then it'll just keep doing the same thing. So this is the repeat. So once we hit this point, we're just going to keep repeating this line. So our period is actually just from here to here. Let's see, so this unit is negative pi, and this one is pi, so this will be negative 2 pi, negative 3 pi, 2 pi, and this one will be 3 pi. Which means our period goes from negative 3 pi all the way to 3 pi, which is a total of 6 pi. Okay. Now, I'm actually just going to write this below. All right, so now we need to find A, B, and C. A is the amplitude, which is 5. Now remember that our period equals 2 pi divided by B. So we know what our period is. It's 6 pi. So 6 pi equals 2 pi divided by B. Let's multiply both sides by B, so we get B times 6 pi equals 2 pi. And now B, divide both sides by 6 pi, so B is 2 pi over 6 pi, which is really just, these pi's cancel out, this is just 1/3. This means that our B is 1/3. And our phase shift is 0, which means our c term is 0. So that means our function is 5 times the sine of 1/3 x. Because just remember, y equals a times the sine of bx plus c plus d. We didn't have a phase shift or a vertical shift, which means that c and d are both 0. And b was 1/3 and a was 5, so we write y equals 5 times the sine of 1/3 x. All right. Now we're going to write an equation of a periodic function with amplitude 20, vertical shift 30, period 2 pi, and horizontal translation, aka phase shift, 6 units to the right. All right. So amplitude is 20. A periodic function. So we can choose sine or cosine. I'm going to stick with sine just for this video. So we're going to choose sine of x. All right, amplitude equals a, which equals 20. Now our period. Our period is 2 pi. And we know that the period is equal to 2 pi over b. So what does b have to be? B equals 1 in this situation. Because the period, which is 2 pi, equals 2 pi divided by b, which is what we'll put in our equation. So over here, I guess I should write y equals a times the sine of bx plus c plus d. So we're really trying to find a, b, c, and d. We found a, and now we found b. Now the phase shift, we're trying to find a phase shift of 6 units to the right, so that'll be a positive 6. And we know that phase shift equals negative c divided by b. All right, so that means 6 is equal to negative c divided by b, which is 1. So we have to find the negative of c, some number c, to equal 6. So this means negative 6 has to equal c. And then this vertical shift 30, well, that's just our d value. So our function is y equals a, which is 20, sine of b, x, so b is 1, so this is just x, plus c, so minus 6, plus d, which is 30, because we're vertically shifting up 30. So this is our function right here, with all of these various transformations applied to it. All right, last part of this video, applying trig functions to periodic phenomena. So the Bay of Fundy in Canada is reputed to have the largest tides in the world. The difference between low and high water levels is 15 meters. Suppose at a particular point in the Bay of Fundy, the depth of the water, y meters, is given as a function of time, in hours since midnight on January 1st, 2020, by this equation. So let's start by just drawing a quick picture of this one. So we've got high tide and low tide, this will be the low tide, we'll rotate up to the high tide, and we'll keep repeating like this, depending on if it's low tide or high tide. High tide's often at night, low tide is during the day. And the difference between here and here is 15 meters. All right, let's actually start with with B. What is the value of A? A, right here, which is the amplitude, which is the distance between a peak and then the midpoint. So that's literally just 15 divided by 2. which is 7.5, because this is the amplitude. Okay. Now the physical meaning of d. There are lots of different ways that you can think about this, but d will be however much, so these is like waves, in a sense. So this d is however much is shifted up, like, from the ground. So d will be actually your average water level. Average water level. For example, if your tide like varies from like 3 feet from a certain point all the way up until, well, I guess 15, so 18 feet. The value of d will be how much is shifted up, which will end up being the average water level altogether. And now the volume of b. So we're going to find the volume of b in this equation. So we're going to assume that the time between successive high tides, successive just means next to each other, high tides, 12.4 hours. All right, so this means that the period is 12.4 hours. All right, and the period, which is 12.4 hours, equals b divided by 2 pi. Multiply both sides by 2 pi, and we get 12.4 times 2 pi. Excuse me, I had this backwards. So sorry. There should be 2 pi divided by b, yeah? All right. So this is 2 pi divided by b, which means multiply both sides by b, and then divide both sides by 12.4 to solve for b, and we end up with b is equal to 2 pi divided by 12.4, which is about 0.507. And that problem will conclude our trig notes. It's really just a lot of using unit circle, knowing trig values, knowing what these trig functions are.
And I didn't really fold them.
Thank you.
I just kind of
Thank you so much.
put them in half. So
Yes, awesome. Thank you.
you are welcome. Now I'm leaving.
Good. Yeah, you're here 15 minutes too late.
So do not stay here too late.
I'm leaving after I finish this video. I promise. Night, Deb. Oh. Okay. That's it for this video, y'all. Email me if you have any questions at all about trig functions, finding trig values, dealing with periodic motion, which is all about trig functions. All right.